Good afternoon. My name is Arushi and I'm 14 years old. I go to step by step and I really learned robotics through what my father, Arushi, likes to do in LEGO. And it is really through robotics that I learned programming. Many of you here would be familiar with LEGO, but you might think of it as a toy making company with little building blocks. Actually, it's much more than that. It provides you with a platform to make robots and learn programming. This platform is called the LEGO Mindstorms. This is an EV3 brick. It is like the brain of the robot. It has an ARM processor. It has a 64 megabyte memory, and it also has an SD card to increase its memory. It has 4 input ports for sensors and 4 output ports for motors. It can be connected to your computer in 3 ways: Bluetooth, Wi-Fi, and a USB cord. These are the 2 types of motors which can be attached to the EV3: the large motor and the medium motor. The large motor has high torque but low speed, while the medium motor has low torque and high speed. These are the 4 types of sensors that can be connected to your EV3 brick: the infrared sensor, the ultrasonic sensor, the color or light sensor, and the touch sensor. This is an IR beacon remote. It has 4 buttons and there is a total of 12 combinations possible. To learn programming, I made a small car. My car, as you can see, has an infrared sensor on the top. This sensor can be used to program it as an obstacle avoider. It also has a light sensor right in the front. This can be used to program it as a line follower. I have used 2 large motors to power the rear wheels and 1 medium motor for the steering of the front wheels. The software which I used for learning programming is the LEGO Mindstorms software. This software is extremely user-friendly and it has a GUI interface. A program can be made by just stringing together small icons, and these icons can be found here. Using this software is extremely convenient as I can work on multiple programs simultaneously. Some really interesting key concepts which I came across while learning programming were loops, trigonometry, data wires, blocks, and arrays. If I have a set of blocks which is being repeated consecutively, then I can just put it in a loop instead of writing it again and again. This really saves time. This is an obstacle avoiding program. What it exactly does is it first centers the wheels of my car, then it drives the car forward until it detects an object. Then the car backs up till the object is out of view and then again continues to move forward. This is in a forever loop, which means that this loop would continue to run the program until I stopped my car. I also used trigonometry in my car. This is a photo of my car. In fact, it's a photo of any car. You can see that the front wheels are turning, but the inner wheel turns on a much smaller circle than the outer one. Thus, it must move slower. V here is the speed of the car, while D is the distance from the center to one wheel. S is the turning radius, A is the turning angle, VL and VR are the speeds of the left and right wheel respectively. W is the angular speed and H is the length of the car. And this is where the tricky part comes in. W is equal to V by S. VR, speed of right wheel, is equal to W into S plus D. This can also be written as V by S into S plus D. It can be further simplified to give V into 1 plus D by S. S is equal to H by tan A, only if the value of A is very small. So the speed of the right wheel comes out to be V into 1 plus D into 0.017 into A by H, and the speed of the left wheel comes out to be V into 1 minus D into 0.017 into A by H. For my car, the values of D and H were coming out to be 65 and 150 millimeters respectively. I put these values into math blocks. You can probably make out the tiny formula which I have written on the top. These math blocks give power to my rear motors to drive the rear wheels. Often in programming, you have to transfer data from one place to another. I am told that in software programming it is done through variables. But while using Mindstorms, I did it through data wires. The output of these math blocks goes into the motor blocks to power these motors. All these yellow wires you see on the screen, they are all data wires. I'm sure all of you guys here want to save time. This is exactly the reason why my blocks was invented. If I have a set of blocks which is being repeated anywhere in the program, and I don't want to write it again and again, I can just make a my block out of it. My blocks are really convenient if they save time, because like I said, I don't have to enter like say 6 different blocks. Just enter one and be done. It also reduces errors. If I have a change to make, I don't have to go to the various places where that block would have been. I can just double click on my block and make that change. This change would be reflected everywhere the my block is present. Also, it makes the program much more compact and easy to view. This is the same obstacle avoiding program I showed you earlier. This part here is what centers the wheels. What it exactly does is that it first turns the wheels to the extreme of one direction, then brings them halfway to center them. But doesn't this look too long and confusing? That is why I use the my block. Much shorter and neater, isn't it? I'll just run this program and show it to you. See how it centers the wheels? When I use my hand as an obstacle, the car backs up. This is exactly what's happening in the program. Being software engineers, I'm sure all of you guys are familiar with arrays. Arrays are nothing but a list of variables with the same name. They can be easily accessed with their indices. Each element in the list has a different index. Scratch is something I'm sure all of your kids are familiar with. Arrays work just like lists do in Scratch. I have already briefed you on the Arya Beacon remote. Let me just revisit the topic. It has 4 buttons. As there is a total of 12 combinations possible, I have used only 9. I programmed my car to detect all these 9 changes and then respond to them. And this is what the program looked like. I had a huge tabular format. I'm only showing you part of it. I had 18 variables, 9 for the speed and 9 for steering. But then I used arrays. And believe it or not, those 18 variables now fit into 2 tiny, easy, convenient arrays. In this program, I'm providing the arrays with indices from this beacon block. I'll just run the remote control program and show it to you. Did you see how my car responded to the changes in the remote? I learned some really important concepts like my blocks and arrays through programming. Therefore, I can say that robotics is the most amazing, most interesting, most epic, and the very best way to learn programming. And also, after making this card and programming it, I really don't find software engineering rocket science anymore. Thank you for watching.